Assalamualaikum. Hello everyone. Ohayo, konbawa, konnichiwa. Welcome. My name is Amir Haziq. For the assignment 2, for the title surgical implant materials, we choose the elbow joint as a product. It is called Discovery Elbow System. Its function is to connect broken elbow to support elbow and its motion if the cartilage deform or and thinning and stress is applied. So the objective that we understand from the product is that we want to reduce wear and tear, minimize oxidation as little as possible to avoid blood contact or any toxic produced in our body must be as light as possible, able to withstand high stress to reduce deformation, crack, and broke on mechanical elbow pad. From the objectives, to fulfill the objectives, the constraint that we structured is must be high fracture toughness that when a porosity or a crack occur over a long time use like years use it, the material might resist any fracture or crack to more worse crack. And then same young modulus for the elbow bone, because the ultimate goal is to produce a product and proper material suitable for human body, lowest density, and no chemical reaction in blood and oxygen, and not produce any toxic. So to fulfill the objectives, there are two the types of material and its design. So here you can see the graph. The graph is constructed based on our objectives and constraints. That is high young modulus, strong as ulnar and humeral bone, but low density. The ultimate goal is a design with a proper material suitable for human use. Therefore, the material index for this graph is to be M equal to E over rho or density. From the graph, on you can see from the graph seen on the right side, the gradient or the slope is the first step to be determined. The dotted line in the graph represent the gradient equal to 1. Then the equation can be derived based on the slope given. Here, if the slope equal to 1, the material indices is equal to M equal to E over rho. But if the gradient is equal to 2, the M will be equal to E square root E divided by rho. Here you can see the line, the thick line in the graph is in between 10 and 1, the value of 10 and value of 1, because the y-axis value is equal to 6.6. So from here, all the materials that are closest to the line are to be performed equally based on the requirement required in produce a surgical implant product. So from this ES, once we already simplify the material, now we want to select among this material that we select, what is the best material to be performed for the surgical elbow implant. The proper way to perform the task by listing all the material specific properties required in elbow mechanical part. So here is the properties that we are seek in producing a surgical elbow part. That is Young's modulus, tensile, compressive, fracture toughness, compatibility, density, and price. Ranking it, the highest the value in strength would earn the highest score. But while the density and price, the lowest the value, the highest score would be earned. In the conclusion, we get the ranking for the humeral and ulnar stem. Remember that humeral and ulnar stem is for metal only, and bearing and cup joint are for ceramics only. So in the humeral and ulnar stem parts, Titanium alloy is the best material with the highest total score of 19. Because of the price of titanium alloy is too expensive, thus the second best ranking is the commercially pure titanium. So we decide the commercial pure titanium to be the mechanical part for Shemuran and Ulna stamp. Why not choose the edge hardening rock aluminum alloy? This is because the edge hardening rock aluminum alloys they contain iron. As we mentioned before, ferrous is not compatible because they contain iron and they react to the oxygen and water that they produce oxidation reaction. Call it maybe like rust for corrosion. This is to avoid that the metal become weakened, brittle, and flaky in a long-term usage. For the ranking of bearing and cup joint, there are two materials that we selected. The silicon carbide will be used for the bearing because of its high fracture toughness and glass surface, and the glass ceramic will be used for cup joint because of its density and price, and because of its unique properties that is glass surface. And that's all from me for the material selection strategy part. Thank you.
First is rapid prototyping (RP), computer numerical control (CNC), hybrid technique with CNC, high precision machining. Next, so for the RP is a group of technique that is used to quickly fabricate a scale model of a physical part or assembly using three-dimensional computer-aided design (CAD) data. Patient-specific instrumentation for enhanced intraoperative accuracy and ease. Modify existing processes designed to suit local needs. So this is the picture for the fixing system used in endoprosthesis manufacturing process.
I want to present about flowchart of the process. The 2D elements of the laser scan vector are built for each layer of the 3D object. For the second, a layer of powder is deposited onto the building platform. Next step is the powder are flattened. The fourth step, the laser beam selectively sinter or melt the deposit powder layer. For the fifth, the powder bed surface is lowered by a height of one layer thickness. And for the last process is the 3D object has been construct, the excess powder are recycled. Then the process second is repeated until the fifth process to get the 3D object. Next, now is the process of from the raw material and last to the warehouse. We start it from raw material to CNC machining process to perfect, and we can decide is with perfectly dimension, and we can check the quality by machining material and move to assemble part. Next we assembly bushing and assembly screw and nut. Next we check the quality assembly part. Then we move to the testing part, and last for the final quality check. Next we go on to the Murray total elbow. We start the packaging, scan, and go to the warehouse.
As you can know, the raw material is processed into manufacturing production, and then the product delivery will take place after the production stage is done. After that, there will be a customer utilization for our process. And last, the disposal recycling is taking place before it is returning into the raw material. For the screening, we are going to figure out what is the process ability suitable for our material. There are cast ability, form ability, machine ability, weld ability, mold ability, and brush ability. For the ranking, our commercially pure titanium has the 3 scores for cast ability, while silicon carbide has no score for cast ability, and glass have 1 score for the cast ability. For the scoring part, machine ability is the winner with 8 points in total, and followed by mold ability with 5 points. The third place shared by cast ability and weld ability with 4 points. The fourth place is form ability with 3 points in total. Brush ability is the last place with only 1 point. In conclusion, machine ability is our selected manufacturing process, and machining has been selected for the 3 materials.
For the material properties, they have a 5 which of linear shrinkage, fracture strength, implant types, tensile strength, and weight. Then the process parameters they have the 6, which are material, shape, part mass, tolerance, thickness, and economy.
For the testing part, we have creating a table for understanding of the medical devices and their biological effects. So in this case, the surface device like skin, mucous membrane, bridge of compromised surface, they have different contact duration, while the external communicating device like blood path, indirect, tissue or bone or intestine, and circulating blood, they have also different contact duration too. And for the implant device, they are consisting of tissue or bone and blood, and each of them has the same contact duration, which are limited, prolonged, and permanent, applied to that of surface device and external communicating device too, which are the 3 steps different. In quality control, we know the Metrotrum 1500 principle. If we are using the X-ray, then we can know that the process of image processing is producing a point cloud for the output, and also surface determination for two outputs, which are surface reconstruction and measurement evaluation. After the measurement evaluation, there will be output of measurement actual nominal comparison defectoscopy. For the quality control part, we use the computer tomography method. There are three parts in here, which are shape deviation inspection, defectoscopy, and dimensional analysis. For the defectoscopy, there will be an inclusion in which there are many air bubbles in between.
They have a three type of the defect, which most like first infection, second stability, and mechanical failure. For the countermeasure of the defect for infection, it must be required to remove the infection with extensive debridement of all necrotic material, including bone, semen, and soft tissue. For instability, it must be a more careful operative technique, ensure appropriate tensioning, secure the repair of the total elbow replacement, and accurate restoration of the anatomic axis. The last for the mechanical failure for the countermeasure is reproduction of the elbow rotation axis and optimal alignment of component can also reduce the stress and reduce stress on the axle and hinge.
In conclusion, design requirement is the required to find the best material, especially material selection strategy like a commercial pure titanium, silicon carbide, and glass ceramic is the selected material. And manufacturing process selection strategy, selective laser sintering (SLS), and every product has its own effect of parameter to its performance. And lastly, product must pass QC test to eliminate defect and countermeasure required for defected parts.